high-strength steel plates increase vehicle safety, while simultaneously reducing vehicle weight, and are increasingly being used in modern vehicle construction. These high-strength steel plates have special material properties that require appropriate tools and techniques, not just for joining. The plasma cutting process is a necessary complement to the cutting processes for bodywork repair and enables fast and defined work to be carried out, not just on high-strength steel plates. The heat input is highly localized, making it possible to carry out relatively cold cuts, despite the high temperature in the plasma jet. The strength of the steel plates is not impaired. Plasma cutting is a process in which an arc is generated using a nozzle in order to produce a high thermal energy plasma jet. The plasma is a very high energy, electrically conductive gas. It melts open the workpiece locally, and the gas flow forces the molten material out of the kerf being formed. We'd like to present the particularly low-emission Fronius Transcut 300 plasma cutting system. This compact unit doesn't use compressed air, which is usual, but a liquid as the starting medium for the plasma jet. As a result, there is no need for a compressed air supply. The operating time, starting with a full tank, is around 3 hours. Transcut reduces pollutant emissions by up to 90% compared with plasma cutting using compressed air. This makes it possible to work without an extraction system if there is a sufficient supply of fresh air. Pressing the torch safety switch initially generates a pilot arc between the nozzle and the cathode. As the cutting torch approaches the workpiece surface, the power source detects a flow of current in the earth cable and automatically switches from the pilot arc to the main arc. The following shows the most important steps for operation of the plasma cutting unit using sample plates. The precautions and safety regulations in the manufacturer's instruction manual must be strictly observed. Before beginning to cut, an earth connection to the workpiece must first be established. Under no circumstances should the earth terminal be attached to the area to be cut away. The unit ready indicator flashes during the warm-up phase and stays on continuously once the unit is ready for operation. The operating mode can be selected. Standard operating mode is recommended for cutting aluminium, and pulse operating mode for cutting steel. The cutting current is set according to the material thickness or cutting speed required. When pressing the torch switch, hold the cutting torch away from face and body. If possible, move the cutting torch over the workpiece in a pulling motion. While cutting, make sure that the arc penetrates the workpiece and that there is as little dross formation as possible. If this is not the case, the cutting current should be increased or the cutting speed reduced accordingly. The cut does not need to be started on the edge of the workpiece. The pilot arc can also be ignited directly on the workpiece. In general, the cutting nozzle and cutting electrode are subject to a certain amount of wear due to the high temperatures. Worn or damaged wear parts must be replaced. Caution: this may only be done after the cutting torch has cooled down. The following shows some example applications of the plasma cutting process in bodywork repair. Please observe the specifications in the service literature and the safety regulations. The Insignia's B pillars have ultra-high strength steel inserts. With the plasma cutting process, these reinforcements can be effectively cut. When cutting out exterior panels, the reinforcements behind must not be damaged, just as with conventional cutting processes. The specifications in the service literature must be strictly adhered to. If there is a space between the exterior panel and reinforcement, it's possible to use the normal plasma cutting current setting and cutting speed. In order to cut at locations where the exterior panel is very close to the reinforcement, the cutting current must be reduced to avoid causing damage. In many cases, especially when repairing larger areas of bodywork damage, the preliminary work requires a lot of time and materials. In this case, the fast and precise operation of the plasma cutting unit offers considerable benefits. Extensive removal of damaged plates can easily be carried out in order to allow access for suitable tools, such as a spot weld drill with C-clamp. In order to prepare connections, in certain service parts and bodywork sections, slotted holes need to be made. Special templates, adapted to fit the cutting torch, are available. Using these templates, slotted holes with dimensions as specified in the service literature can be produced. The plasma cutting process, in combination with templates, is extremely efficient, particularly when producing slotted holes. The template is securely attached to the workpiece using locking pliers or held manually by the handle. Compared with their competitors, Opel vehicles are distinguished by their low post-accident repair costs. The Opel Insignia's repair-friendly concept includes bolted connections instead of welds at certain defined points. During a repair, there is also the option, provided for in the design, of replacing connections which were initially welded with equal strength bolted connections. These measures are part of an overall concept that allows grading of repair work according to the severity of the accident. In low-impact speed collisions, the bolted front bumper and left and right energy absorbers absorb the forces, so the bodywork structure behind remains intact. In the case of more severe bodywork damage, where the side members are also affected, defined separation points allow specialist workshops to perform economical partial replacement using the corresponding ready-made frame section parts. In the following, a body in white is used as an example to illustrate the most important steps. The necessary safety regulations must be observed for all work. Likewise, all the requirements and specifications in the service literature and all necessary corrosion protection measures. To replace the front bumper energy absorber, first remove the bolted front bumper. Then unscrew the mounting bolts of the energy absorber and drill out the 4 spot welds on both flanges. The energy absorber can now be removed. The new part is attached to the side member using 4 bolts, but not yet tightened to the required torque. Instead of being welded, as before, the connection is now bolted. For this purpose, 2 6mm holes must be drilled in the flange on both sides. Before the final attachment, corrosion protection measures must be carried out. Finally, the bolts on both sides are torqued as specified in the service literature. To partially replace the upper front frame extension, first remove the bolted upper front cross member. As well as the upper headlamp bracket. The cut must be made above the laser weld. Mark the cutting line as specified in the service literature. To achieve as straight a cut as possible, the upper front frame extension and the closure plate are cut out using a disc grinder. After transferring the cutting line from the removed part, the new upper front frame extension part and the closure plate are cut approximately to size. The new part is prepared for installation and positioned on the bodywork, and the precise fit is checked using a measuring system. The parts are joined using MIG brazing. Then apply structural adhesive to the flanges and position the closure plate. Install the new part and the closure plate by spot welding at the flanges, and MIG brazing at the butt joint. To replace the upper front frame extension, first remove the front bumper energy absorber, the bolted lateral wing bracket, and the bolted lower and upper headlamp brackets. To remove the lateral front panel, drill out all spot welds. Then detach the panel. The relevant spot welds on the exterior of the closure plate are first located and then drilled out using a spot weld drill. In addition, the first and last spot welds in the lower row must be drilled out from the inside. The spot welds on the side member can only be milled out using a ball end mill. To avoid weakening the material as far as possible, repeatedly check how far the welded connections have been opened. The spot welds on the rear side must also be milled out. In the area of the side member is an adhesive connection. This must be detached before the part can be removed. The section required for the replacement is drilled away from the exterior side member service part. Subsequently, prepare the detached section and the upper extension service part for installation. The bodywork should also be prepared as specified in the service literature by grinding the flanges to bare metal and producing slotted holes. The upper extension service part is now positioned on the bodywork and adjusted to fit. The installation position of the exterior side member part section can now be checked. Now, remove the part section, apply adhesive to the bodywork flange and reposition the part section. To secure, first braze the slotted hole, then carefully remove the upper extension service part. Additionally, secure the other side of the flange using locking pliers and spot weld the bonded flange. To achieve optimal corrosion protection, the adhesive is applied both to the bodywork and to the new part. The adhesive must be spread over the surfaces of the service part as well as the corresponding areas of the side member. The service part is now repositioned, aligned and secured to the bodywork. The installation is completed by spot welding and MIG brazing as specified in the service literature. Before the adhesive has cured, the energy absorber must be reinstalled. To carry out partial replacement of the short front frame, the wheel well strut must first be removed. After marking the cutting line, locate and drill out the relevant spot welds. Then carry out the separating cut. In order not to damage the underlying plates in the flange area, a suitable tool should be used to carefully carry out the cut. Using a splitting chisel, detach the wheel well strut and remove it. Then remove the seam seal. To continue removal of the short front frame, the repair area must first be extensively exposed. The flanges are now easily accessible so that the spot welds can be drilled out using a spot weld drill equipped with a C-clamp. In the next step, the support for the battery tray is removed. Then, the spot welds on the rear flange of the short front frame are drilled out. In addition, a further spot weld in the front area must be drilled out as it connects the plate with the reinforcement behind. Detach this spot using a drift punch in order to avoid deforming the reinforcement when removing the part. To mark the cutting line on the exterior of the front frame, note the dimensions of the new part. Don't cut too far towards the rear in order to avoid damaging the underlying reinforcement and to keep sufficient material to allow precise fitting of the new part. Carry out the cut and, as before, cut carefully in the flange areas to avoid damaging the underlying plates. After it has been detached, the short front frame can be removed. Prepare the bodywork for the installation. And grind the short front frame service part to bare metal at the flanges. Produce slotted holes according to the specifications in the service literature. Now position the short front frame service part on the bodywork and check the fit. Positioning using a universal welding gauge in combination with an electronic measuring system is described in Chapter 4.6. Apply structural adhesive to the flanges according to the specifications in the service literature. Position the short front frame. Check the installation position. And spot weld at the flanges. Please note, the interior reinforcement must also be spot welded initially in the front area. Then position the cover plate. Secure using clamps. And cut along the new part. Remove the protruding metal strip. Now, the second spot weld for the interior reinforcement is also accessible. Subsequently, apply structural adhesive to the flanges and reinforcement according to the specifications. Position the cover plate and spot weld at the flanges. MIG braze at the butt joint. Likewise, MIG braze all slotted holes in the repair area. The following shows the partial replacement of the long front frame on a body in white that has already been prepared. The lateral front panel, the wheel well strut, the wheel well strut reinforcement, and the complete wheel well have already been removed. In the first working step, using a spatula and a hot air blower, the adhesive between the rear side member and the cover plate must be detached. All spot welds in the section for removal should be located and marked. Then drill out the spot welds. There are several layers of metal at the rear side member. After the spot welds in this area have been drilled away from the outside, they must also be drilled out from the inside. The outer holes can be used as a guide. When extensively cutting open the area, the position of the reinforcement in the rear must be taken into account. One spot weld on the reinforcement only becomes accessible after removal of the outer plate. As specified in the service literature, make slotted holes in the long front frame service part and grind the flanges to bare metal. Now, position the service part on the bodywork in order to define the position of the slotted hole on the reinforcement. The service part can now be secured to the prepared bodywork for installation. Check the installation position using a measuring system. Subsequently, install the long front frame by spot welding. And MIG brazing. Due to the special material properties of the Sill reinforcement steel on the insignia, a partial replacement in this area was previously not permitted. The following presents an advanced adhesive and rivet technique using backing plates and high-strength steel rivets. Use of this repair process ensures that the vehicle's structural properties remain intact. To carry out a partial replacement of the sill reinforcement, the exterior panel is removed and the cutting line is defined. In order for the backing plate to fit correctly, the line must run centrally between the two reinforcements. Subsequently, perform the cut. Drill out the relevant spot welds. And remove the damaged part. The sill reinforcement service part is now cut to produce the required repair plate. The backing plates can be manufactured from the cutoff. Fit the repair plate to the bodywork with a gap of around 1 millimeter at the butt joint. Then secure the upper backing plate for drilling the rivet holes. Drill 4 holes with a diameter of 6.8 millimeters. This hole diameter is due to design considerations. Secure the lower backing plate as well and drill 4 more holes accordingly. The pre-drilled backing plates are now secured using bolts for the time being. The new part can now be positioned and secured. Subsequently, the other rivet holes can be drilled. The repair area must be prepared according to the specifications for welded, soldered and riveted connections. This includes removal of the cavity protection wax. Only the specified sill reinforcement rivets may be used. The structural adhesive is spread on the backing plate and the plate is placed onto the bodywork. Rivets are inserted in order to position the plate correctly. Riveting is performed using a compressed air rivet gun. The lower backing plate is installed in the same way. Structural adhesive is then applied to the protruding parts of the backing plates and to the flanges. First, position the repair part on the bodywork by inserting rivets, and only then secure using clamps. The installation of the sill reinforcement repair part is completed by riveting the backing plates, and spot welding the flanges. Finally, the required corrosion protection measures can be carried out. In order to correctly repair vehicles with accident damage, electronic measuring and straightening systems are used. These systems ensure a quality vehicle repair. Complete repair documentation facilitates communication with customers and insurance companies. New body panels can be accurately welded into place. By constantly comparing actual and target values during straightening work, the alterations carried out can be accurately recorded. All necessary vehicle data are available from a continuously updated database. Opel Vauxhall recommends the use of measuring and straightening systems by the following manufacturers: Black Hawk, Carbench, Sillet and Carolina. The user instructions and regulations from the system manufacturer must be observed. The following shows the general approach for repairing accident damage to cars using, as an example, a system by Carolina. If the possibility of damage to the frame cannot be ruled out in the course of an assessment of accident damage, a vehicle measurement must be performed. Before carrying out a vehicle measurement, the stress in the deformed bodywork must first be relieved. Caution: if vehicle measurement is performed with stressed bodywork, it's impossible to achieve true measurement results. To relieve stress in bodywork with frontal damage, the axle bolts are loosened and the front cross members removed. After relieving stress in the body structure, there is an initial recovery of the deformation. This recovery is what allows a realistic assessment to be made of the state of the damage. In many cases, recovery of deformation in body panels will bring the panels back within the allowable tolerances for the nominal state. In preparation for vehicle measurement, an order is created and the vehicle-specific data set is selected from the database. Then the system must be adjusted. By comparing the measuring points to the nominal values, the system determines the correct adjustment, which is confirmed by audio and visual signals. At least 4 measuring points are specified by the vehicle manufacturer, each of which is measured in turn using the measuring tip specified. Caution. In order to capture the measuring points during adjustment, the car must be raised at the sill. Depending on the type of vehicle, the fold may require rework and resealing. For the actual diagnostic measurement, the measuring system database displays the points to be measured using an overview diagram and a photo database. It's possible to move to these points individually. A measuring report is automatically generated in the process. Beginning at the largest deformation, all 3D coordinates relevant to the damage are determined on the basis of the predefined measuring points, resulting in an accurate damage record. Using various different adapters and extensions, all relevant measuring points can easily be reached. When measuring points in the nominal position are reached in the respective measuring range, the measuring process is complete. Finally, a record of the measuring process is printed off. The record can also be saved. The measuring reports are used as the basis for damage calculation. Depending on the extent of the damage, the required repair measures are defined. At this stage, the requirement for use of a straightening bench is decided and the general repair procedure is defined. Based on the damage report and the service instructions, the required service parts are defined. The stored reports support communication with insurance companies and assessors. To carry out repair work, the engine, transmission and front axle are removed. The vehicle is pulled onto a straightening bench and raised to the working position. The clamp positions are specified for each vehicle and must be taken from the respective data set and transferred to the vehicle. Subsequently, use a hydraulic jack to raise the vehicle. Remove the transport trolley and attach the clamps at the specified positions. The vehicle can now be firmly anchored. The measuring system is now readjusted to the vehicle on the straightening bench. In order to do this, the system function must be switched to engine removed. The required switch to assembly units removed is also performed. This is necessary in order for the system to import the adjusted measuring points from the data set. The procedure for adjustment is the same as described in Chapter 4.2. In addition, the measuring points that have changed due to removal of the assembly units must be re-measured following adjustment. Electronic measuring and straightening systems enable real-time monitoring of measuring points during the reshaping and straightening process. During the reshaping and straightening process, the overall structure must be monitored and checked if necessary. To avoid adverse deformations, it may be necessary to establish additional anchor points. Then, the straightening process can be continued in a controlled manner. Due to the material properties, it's often necessary to pull a body panel beyond its nominal position. Using the real-time monitoring feature, you can incrementally approach the nominal value, thereby avoiding any resulting damage. After removing the anchor points, a repeat inspection of the measuring points is carried out as a final check. Positioning a service part using a universal welding gauge is shown here using the replacement of the short front frame as an example. The service part measuring point is selected from the data set. The system then specifies the anchor point for the welding gauge. Animated assembly instructions explain step by step how to fit the welding gauge. Using a universal welding gauge in combination with the electronic measuring system, service parts for all vehicles can be accurately positioned. This means that the use of vehicle-specific straightening fixture sets is no longer necessary. With the welding gauge set up, the service part can be positioned on the bodywork with the correct measuring point value. Check the fit of adjoining components. Having inspected the other measuring points, the repair can then be correctly completed.